Hi there, and welcome to my channel. In this question, we are given the function f, which is defined by the power series f of x for all real numbers x for which the series converges. And we are asked in the question A, using the ratio test, find the interval of convergence with this power series. And so what is the ratio test? The ratio test says that the limit as n goes to infinity of the ratio of an plus 1 over an has to be less than 1 in absolute value. And so let's see whether that's the case here. Limit as n goes to infinity, plugging in the values for an plus 1, we get negative 1 to the power n plus 1 times x to the power 2n plus 3 over 2n plus 3 divided by an term negative 1 to the power n times x to the power 2n plus 1 over 2n plus 1. The absolute value is here, so we don't care about negative ones. And then dividing by a fraction is the same as multiplying by a fraction. So this is equal to limit n goes to infinity of the following two ratios, x to the power 2n plus 3 over x to the power 2n plus 1 times 2n plus 1 over 2n plus 3. And this is equal to, in the first ratio, we have this limit as n goes to infinity of x squared times the ratio, which is 2n plus 1 over 2n plus 3, and this is equal to the absolute value of x squared. And this has to be equal or less than 1 in order for this series to converge. So x squared less than 1, this means that x squared is less than 1, which means that x is between negative 1 and 1. So in order to find the entire interval, we also have to check x equal to negative 1 and x equal to 1. And for x equals negative 1, we see that the series is equal to negative 1 plus 1 over 3 minus 1 over 5 plus and so on, plus the term negative 1 to the power n plus 1 over 2n plus 1 plus and so on. So this is alternating series whose terms decrease in absolute value to 0, and by the alternating series test, this series converges. And similarly, for x equals to 1, the series is 1 minus 1/3 plus 1 over 5 plus and so on. The general term is negative 1 to the power n over 2n plus 1. And again, the similar argument by alternating series test, because this series terms are decreasing in absolute value to 0, it also converges. So the interval of convergence includes both endpoints. So the interval here is from negative 1 less than or equal to x less than or equal to 1. Let's move on to part B. In this question, we need to show that the absolute value of the difference between the functional value at 1/2 minus 1/2 is less than 1 over 10. And here, because the series for f at 1/2 is an alternating series whose terms decrease in absolute value to 0, the first term of this series f of 1/2 is equal to 1/2 minus and then 1/2 cubed over 3 plus and so on. The first term is actually 1/2, so f 1/2 minus 1/2 in absolute term is less than the next term, the most of the absolute value of the second term of the series. So it's less than 1/2 to the third power over 3. And this is equal to 1/2 cubed is 1 over 8 divided by 3, 1 over 24, which is less than 1 over 10. So that's how we show it here. Let's move on to part C. In this question, we need to write the first 4 non-zero terms and the general term for an infinite series that represents the derivative of this function. And so to find this derivative, we need to just differentiate f of x element by element. So this is equal to the derivative of x is 1 minus x cubed over 3 is x squared plus x to the 4th minus x to the 6th plus and so on, plus differentiating the term here, the general term gives us negative 1 to the power n times x to the power 2n. Let's move on to the last question here. In this question, we need to find the value of f prime at the point 1 over 6. And so from part C, f prime of x is equal to 1 minus x squared plus x to the 4th minus x to the 6th plus and so on. So f prime at 1 over 6 is equal to 1 minus 1 over 6 squared plus 1 over 6 to the 4th power minus and so on. So we can see that this is actually a geometric series such that a, the first term is equal to 1, and r is equal to negative 1 over 6 squared, or equal to negative 1 over 36. And this geometric series f prime of 1 over 6 is equal to a over 1 minus r. Plugging in these values gives us 1 over 1 minus negative 1 over 36, which is 37 over 36. So this is the answer to this question. Thank you for watching. If you liked this video, please don't forget to click the like button. Write me a comment below and subscribe to my channel, where you can find more solutions to the AP Calculus AB and AP Calculus BC problems. And I will see you in the next video.